right, guys, we're going to be looking at graphing trig functions. This shouldn't be too big of a deal for you, especially since it'll be open notes and you'll have all that right there with you. But we're just going to look at how to do sine and cosine today, and then we'll look at the other four tomorrow because really it's sine, cosine, and tangent, and then the other three they just build off of the first three. You'll see that tomorrow. So we'll check out sine and cosine. Before we get started, I got a couple dumb dad jokes for you. First one is, what's brown and sticky? A stick. And then the next one is, so there's this woman who got put on trial because she kept hitting her husband with his guitar collection. So the judge asked her, first offender? She goes, no, first one was a Gibson, then offender. All right, guys, so what we're looking at today is how to graph sine and cosine functions. And the reality of graphing sine and cosine functions is really not how we're going to go about it, because if you actually graph them by plugging in x's and y's, which I'm going to demonstrate once, if I were to do that, it takes a lot of time. And I mean, you'd have to graph probably, I don't know, at least 10, 15 points to kind of make sure you know what you're doing. Maybe not quite that many, but a bunch, and it's very tedious. So let me just give you an idea of how that would actually play out, and then I'll actually show you the little tricks we use to graph these. Okay, so the first thing I want to talk about is, let's just think about this first graph, this y equals sine of x, as just a function. So y equals sine of x, and if I was going to plot points on a curve, I would need to, I don't have to make a chart, but I'm basically going to plug in a bunch of x values, find their y values, and then plot those points. Now, the way I've set up this sine curve, you'll see, is I'm going up to 1, down to -1, or actually I'm going up to 3, but this graph only has a height of 1, and it only drops down to a depth of -1. But I'm plotting points, and you can just see the final graph, and you can ignore these dotted lines for now. So what I'm doing here is I'm taking the sine of an angle. Now, I know you don't see the theta in there because I want to graph this on an x and a y axis. So I'm using x for the angle, and then the sine of the angle gives me these values or these ratios. So if I use angles that I'm familiar with, like 0 degrees, and then 30 degrees, and then 40, well, you could use 45, I'll throw a 45 in there, and then 60, and then 90, and then I just kept doing all of these values. Sorry, I should have put the 45 in there. But you see, at 0 degrees, the sine of 0, and you know that because when you go to your unit circle, the y value at 0 degrees is 0. And at 30 degrees, if you go to your unit circle, the sine, remember the sine of the angle is the y value. The y value is a half, so I'm just going to write 0.5. All right, and then at 45 degrees, I'll jump down there. The sine of 45 degrees is square root of 2 over 2. Now, to help us with this, since the square root of 2 over 2 doesn't mean a lot to a lot of you, like if I asked you about what is that decimal, let me go ahead and just show you. The square root of 2 divided by a 2 is about 0.707. So I'm going to think about square root of that is approximately 0.7. And I should have done these in order, like 0, 30, 45, 60, 90, but bear with me. Now, 60 degrees. The sine of 60 degrees, if I were to plug sine of 60 in there, I end up getting the y value at 60, which is root 3 over 2. Well, again, that probably doesn't mean a lot to a lot of you. So I'm going to type in the square root of 3, all of it divided by 2, and I can do that with a fraction also. And you see that you get about 0.86. So about, I'm going to say 0.86, actually 0.866, so about 0.87, 0.9, somewhere close to 0.9. And then at 90 degrees, sine straight up at 90 is equal to exactly 1. Now, if I were to go plot these back on our graph, the way you're going to see your graph, and I'm sorry I can't do a lot better than this, but we're going to be graphing all of these functions in terms of radian values. Okay, so not degree values. So you're going to be seeing radian values in these things, and that's typically what we do. But I think you're with me in that you know that that 30 degrees is pi over 6, 60 degrees is pi over 3. You know at 45 is pi over 4, and 90, which is straight up, is pi over 2. And 0 degrees is the same thing as 0 radians. So think about this. At 0 radians, and I've marked this in terms of 0, that's 3.14, so that's your pi right there. 6.28, that's your 2 pi. So if that's pi, this is a half a pi, and you can see from our little table we've made up right here, a half a pi was equal to 1. So you can already see that I'm up at 1 right there, right? And then if you keep looking at these, you know that at 0 ratings, I'm at 0. That's right here. And if I were to go through there and start looking at all the other ones, this dot is bothering me a little bit right there. If I look at these other values, 1/6 of pi, right? If that's pi, or 3.14, pi over 6 is 1/6 of pi. So if that's pi, that's half a pi. I would have to like break this up into thirds and this up into thirds so that I'd get 1, 2, 3, 4, 5, 6 parts. So at pi over 6, I'm up at a half. Well, look, there I am. And at pi over 4, which is half of a pi over 2, that's like right in the middle, that's up at about 0.7. It's about right there. And then you can see right here, pi over 3, which is 1/3 of pi, or 2/6 of pi is right there. If I took that all the way up, I'm getting about a 0.8, 0.9. And then right there, I'm at 1. Well, guys, I think that I think you're with me. But bottom line is, that's just what, 1, 2, 3, 4, that's 5 points to just get that. I would have to now go beyond pi over 2 to 2 pi over 3, and then to 3 pi over 4, and then to 5 pi over 6. And I would have to go through all those other values of the unit circle to get these points right here. And then I'd have to go, that would just be going through 180. Then I'd have to do the same thing all the way down through 360 to get these other values of pi that show up here as well. So it would be a lot of points. Again, 5 points just to get through the first part of this sine curve. I'd have to have another 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So lots of points I would have to plot to get this curve. Now, the interesting thing about sine curves and all the trig functions is that once I get through that 360 degrees or 2 pi, it just repeats the process again. So if this is what it looked like for the first 2 pi, it's going to continue to look that way from 2 pi to 4 pi, and then from 4 pi to 6 pi, 6 pi to 8 pi. And also, you're going to see the same repeating thing from negative 2 pi to 0. Look, up, down, or from negative 4 pi to negative 2 pi. And we say that these have what we call periods. And these periods, we say that a function has periodicity, right? I'm not going to make you say that word or use that word, but that's a period, which is, the period is the entire cycle of the actual trig function. And we're going to talk about the cycles of all 6 trig functions, but sine and cosine behave in a similar way. Okay, and we'll talk about how you actually determine the length of that period. Now, this particular graph is a very basic sine curve. All right, now you're going to see that as I change parts of this sine curve and start making it look like this, like where I might have a number added to the sine curve, and I might have a number plus or a number minus, and then another number multiplied by the sine curve. And then instead of having a single x, I might have something multiplied by the x. And then instead of having just a number times x, I might have something subtracted from that. And all of these things are going to shift, reflect, stretch, and do all the same things that happened when we did that to the 13 basic functions. And these last 6 will be the last ones. Okay, so we'll have 19 functions we'll know how to graph, basic ones, when we head into next year. Okay, now I don't ever want you to plot points to graph again. Sometimes that was a good thing to do when you had exponential functions or log functions and you got kind of lost. You're not going to want to do that here. You're probably never going to get done with your test. What you'll want to do is show me that you understand some of these trends. So let's look down at something like this and let's talk about what each of these values, the D value, the A value, the B value, and this negative C value, I'm just going to call it the C value, but you're subtracting it. And then also what that plus or minus does to a normal sine curve. And what you're going to see is all of these 4 values, including that plus or minus, they are going to change the length of your period. So instead of taking 2 pi to complete a cycle, I might complete a cycle in pi, which means you're going to go up and down before you even hit here. It might take you 4 pi to do it. So you might go up to there and then down to there. Also, you might not just go up to 1 or down to 1. You might go up to 5 and down to -5. Also, you might not start here on this x-axis. You might start up 2 or maybe down 3. So, and then also, you might not start right here on this y-axis. You might start over a little bit before you start up and down. All those things are affected by the A, B, and the C, and the D, the plus, the minus, and whether it's a sine curve or not. Okay? But what I want you to understand is that every sine curve is going to fit in what I call a box. Okay? Every time you see something, 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 something sine like this, then you can expect your box in the end is going to look something, whether the box looks normal, kind of normal looking like this, and you're going to be literally learning how to mark these values, whether or not it actually is really thin and long. You might have a box that looks kind of like this, okay? You also might have one that's really short this way, but really tall. Okay? And again, like I said, you're going to learn about how to sketch in the tops, the middle, and the right and the left side of these boxes and create a box. And once you have it, I think what you'll see is in every box, kind of like you see here, once you have that box drawn in there, which is going to illustrate the length of the whole cycle, you know that you always are going to start right there at the beginning. So at the beginning and at the end, on that middle line, you can always mark points. This is going to make a lot of sense in a second. All right? It's always going to be that way. And then you're also going to know in the very middle of the box, there's always going to be a point. So if you can eyeball it and find the middle, eyeball it and find the middle, eyeball it and find the middle, you're always going to have a point. And those are going to be 3 of the 5 points you're going to sketch. Now, how do you determine the next one? Well, if it's a regular all positive sign, then you're going to put a point up and a point down at the quarter. So you're going to basically go in between that ending one and the middle one. You're going to find the middle and you're going to go up there and down there if it's a positive sign. Okay? Now, if it's like the one right below it, which was a negative sign, you'll see the only difference is instead of going up first and then down, you go down first and then up. So on this particular one, if this had been a negative sine of x, I'm still going to have those same 3 in common, but you're just going to find halfway there and go down first, and then halfway there and go up first. And you're going to sketch your graph, just eyeball it. You're not going to worry about plotting all those points. You're just going to eyeball it like this. This one, you're going to kind of eyeball and sketch a little bump down and then a bump up. All right? So I'll do one more here. We'll just say this was also a positive sign, and you already figured out what the A, B, C, and D did, but we don't know that yet. But if you did, you'd go, oh, positive sign. Well, whether it's positive or negative, I know I have those 3, kind of like Orion's belt, if you know any astrology or whatever. And then in the middle of that, you're going to go up to the top of the box. In the middle there, you're going to go down to the bottom. And then you're going to connect those 3 dots with a bump up and those 3 with a bump down. Now, a lot of people try to graph these without marking those points, okay? I would strongly discourage that, all right? Because I'm looking to see if you've gone through those 5. So if you don't mark them and you just make your, like if you do something like this is not good. But let's just say you got your box right here and you've gone ahead and you've labeled everything, which I'm going to show you how to do all that in a second. And you go, oh yeah, sine curve. I know those, and it's let's just say it's a positive sine curve. If you look at this and you go, oh yeah, I know it bumps up first and then it bumps down, and you just fit it in there, I'm going to go, wait a minute. He didn't find the very middle, the 3 points of Orion's belt. It should have gone through right there, shouldn't it? And then halfway there, it should have gone up. Now, I might give you credit for that because you're close, even though I can tell you missed. And then halfway there, you're supposed to be down there. You actually did hit that point, but you totally missed this, didn't you? And that would be a good way to get yourself dotted or slashed or who knows what. Okay, so make sure you're marking these 5 points. And if you're doing that for positive signs like this or for negative signs like this, you're going to be in great shape on these. So the key is getting this, what I call getting the box drawn. Okay, and you're going to be drawing the box for sine, cosine, secant, and cosecant. You're going to be sketching a little box in there, and that's going to be helping you graph all these. And you will see tomorrow that secant and cosecant are very much like sine and cosine. All right, and then we'll do a little bit something different for tangent and cotangent, but you'll see that also tomorrow. Okay, so now let's talk about how I determine where the beginning and the ending and all that kind of stuff, how I determine where all that stuff shows up. Okay, so here's what we're going to do. If we're looking at this, there are 4 things that I have to learn that are going to help me sketch the top, the bottom, the middle, and the sides. And the very first one I want to look at is called the vertical shift. And the vertical shift is just whatever the D value is. If the D value is a positive number, then I'm going to shift the graph up or down. So basically, this middle line that you have, that represents my D value. Okay, so in this case, you can see that I was adding nothing to sine. That's why D was 0, and that's why my line was there. But if I was doing something like 2 plus sine, I would have started this graph by shifting it up 2. And I would have had a dotted line there representing this. And my whole box gets shifted up with it. Okay, and we're going to do this in a second a number of times. So that's the vertical shift. I always want to deal with that first. Okay, so when you get that value, put a dotted line, kind of like y equals d, put a dotted horizontal line through there. All right, and my advice to you guys is on this work and this homework, print out. You have actually these sheets at home already, which is great. Actually, never mind about the printout. I would definitely have a plan to be able to print something out for your test, because sketching these on a sheet of paper is going to be really tough. You're going to have to be really good. So maybe start thinking ahead about a plan for this Friday about being able to print, because I'm probably going to send the test to you. You're going to print it, do it, and then send it back to me, and you'll have like an hour window or whatever to be able to get that done. Okay? All right, so let's check this out. Next thing is the amplitude. So the amplitude is how high or low the graph goes above or below the vertical shift. So you can see here from this, I went up 1 and down 1. That's because there was a 1 in front of the sine curve. The 1 is the amplitude. That's like the A value. Now, we are going to ignore the plus or minus, but the second thing I want to do is look at that. So whether it's plus or minus for right now, ignore that. Look at this number, the A, the actual number right there. That tells you how high and low you're going. So if you're sketching your box, if your A value is 3, instead of going up 1, I'll go back to this one right here. Instead of going up 1 from your D, you'd go up 3 and go down 3, and you draw dotted lines above and below. If it's 2, go up 2 or down 2. Now, you don't go up or 2 from the x-axis. You go up or 2 from whatever your D axis is. That's why you do the D first. And again, you're going to see me doing this. I'm just walking you through it. All right, so at this point, we're going to have the middle line and the top and the bottom drawn. Now we need to figure out what the left side is. Well, the left part of the box is what we call our phase shift. Okay, now the phase shift is technically C over B. Now the problem with that is your equations are always written in BX minus the C over the B. So you're always having to change your signs. Well, the easiest way I know to do this to cut down on errors, guys, is just take your BX minus C part, the part that's in parentheses, just set it equal to 0 and solve for the X. If you do that, you're going to be adding the C, hence changing the sign, and dividing by B. So if you want to find the phase shift, take that right there, the BX minus C, whatever it is, set it equal to 0 and solve, and that tells you where to go. So let's just say I solved and I got something like negative pi over 2. Well, I would go back over here and I'd go, well, if this is a negative pi, then this is a negative a half of a pi. And I would put a dotted line there for the left edge of my box. Here, the left edge was at 0 because I'm not subtracting anything, right? If I take all of that and set it equal to 0, I get x equals 0. So that's why my edge of the box was there. We call that the phase shift. Okay? And then the very last thing, sometimes people have issues with that, but I don't think you will after I go over it a lot. But it's the length of the cycle, which again is called the period. Now, I labeled this, that this right here was one period. I think in the context of what I was saying, I said periods. But this is a period. There are all kinds of periods for this sine curve that just keep occurring forever and ever and ever. But the length of that period is what I'm looking for, because I want to know how long it takes, how long and skinny this box is, or how long period it is. Well, that's what the period finds. Well, the way to do the period is literally for sine and cosine, you always take 2 pi, because 2 pi is the normal length of a very plain cycle like this sine curve. It was 2 pi. But sometimes there's going to be a number with that x, and the number with the x changes the length of the period. So what I'm going to do here is I'm going to take 2 pi and put it over, to find the length of the period right here, I'm going to take 2 pi and put it over the b value. Okay, so 2 pi over b. We're going to actually use this later in a couple of days. So if the b value is 3, that tells me that my period has a length of 2/3 of a pi. If my period is a half, if my b value is a half, then 2 pi divided by a half, I would multiply by 2 and I get 4 pi. That would tell me my period is 4 pi lengths long. Well, you just got to go up to the graph and make sense of that. Like if my period was a half of pi, that means from the left edge of my box, I got to go over a half a pi. And that would be a really tiny up down, right? Really small box right there. If my period is 4 pi, from the edge right there, I got to go over 1, 2, 3, 4. That would be a really long box, which means I'm going up there, down there. And you'll see that the more I do it. But guys, we're marking one box and we're doing one box at a time. Okay? So this is the first thing, the vertical shift, then the amplitude, then you got to do your phase shift, then you're going to look for your period. And you're going to find those 4 things. And then once you get the box made, then you go back and you say, all right, what did the plus or the minus and the sine actually do? Okay? So I'm going to do maybe one of each, maybe a positive and a negative sine curve, and then we'll come back and we'll talk about how cosine is almost the exact same process, except the points look different, but the whole box part of the thing is exactly the same. All right, so the first one I'm going to do, and keep those notes handy. Also, you'll have them for your test right there in front of you. You don't even have to learn those, this year. So I'm going to be graphing this function right here. So I'm going to go through my steps. So what was the first thing I asked you to do? It was to find the vertical shift. The vertical shift is the d value. That is the d value. So that tells me that y equals that is my center line on my box. So I'm going to go to -2, and I'm going to do y equals -2 all the way across. This is a really good time. I know girls, especially last year, normally girls, not many guys did it, but it's really helpful. Get a marker with a thicker edge than this, and just put your dotted lines in there. It's a whole lot easier to be able to see this. Okay? All right, the second thing I asked you to do was find amplitude. Amplitude, I'm ignoring the plus or the minus, and I'm looking at just that. So if I ask you, what is your vertical shift? The vertical shift right there, I would say the vertical shift is -2. And if I say, hey, what's my amplitude? I would say my amplitude is 2. And I'm always making the amplitude a positive value because it's kind of like a length. All right. So what that means is if the amplitude's 4, don't start here and go up 4. Start at your d value, which was -2, and go up 1, 2, 3, 4 from there. 1, 2, 3, 4 from there. So 4 up and 4 down, because your amplitude goes that much up and that much down, and that's going to give you more dotted lines right here. And you don't have to be perfect about it. You're just trying to show them. Now, sometimes people ask me, do I have to put those in there? Again, if your graph is perfect, I don't care. Okay? But I would actually, this year I do care. I'm going to want you to put those in there. Okay? So make sure you but use it you don't have to do a ton of dots. Get a marker, a magic marker or something that's a little bit thicker than this pen or a pencil, and just put dotted lines. It'll be really easy to tell. All right, so now I've got the amplitude in there. Now the third thing I asked you to do was to find the phase shift. Now what did I say to do to find the phase shift? Okay, so the phase shift is like a horizontal shift, right? I said take that, all right? So I'm going to take 4x minus pi over 2. I'm going to set it equal to 0 and solve. So the first step would be to add the pi over 2 over. And I know a lot of people divide by 4. It's going to look a whole lot better if you just multiply by a reciprocal. It's a lot easier to tell. So what do I get for my phase shift? Pi over 8. Now let's make sense of that. What is pi over 8 means 1/8 of a pi. 1/8 of a pi. What's pi on this number line? Well, on this number line, that's pi, right? 3.14 is pi. So I want to go to 1/8 of this pi. Well, if that's pi, 1/8, I would need to break this up into 8 tick marks. Oh my gosh, it's 1, 2, 3, 4, 5, 6, 7, 8. You're going to see a lot of kindness there. So if 1/8 would be right there, that would be my pi over 8. So this gives me right here the left side of my box. So now I've got the top, the middle, the bottom, and the left side. So all I need now is the right side, wherever it is. That is the period. So to find the length of my period, what did I tell you to do? I told you to take 2 pi and divide it by the b value, which was 4. So that gives me 1/2 of a pi. Now here's where you got to be careful here. This is a length, okay? And each one of your graphs that you have is going to be labeled differently. Sometimes this right here is pi over 2. Like in this case, if that's pi, 1/2 of 3.14 is 1.57. This right here is pi over 2. So, but this does not mean to go right there and end it. This is a length. So what you have to think is almost like a ruler. To get from here to there, how many tick marks did I go through? 1, 2, 3, 4. So this length is 4 ticks on this ruler. Okay? Now on this ruler, if you go down and look at the other one, this pi over 2, 1.57, pi over 2 was 3 ticks. If you look down at the very bottom at number 3, if this was pi over 2, it's 2 ticks. So it's all dependent on the graph. So since this length of the period on this one was 4 ticks, from here I'm going to go 1, 2, 3, 4, and that is how the length of my period. So it's the length, the period is not a location, it's a length. Okay? And that is 1 period. And I really hope that right now you see what? You see the box. See it? There's the top, the middle, the bottom, and the 2 sides. And what did I say to do on every time you see a box? Well, if it's sine, you have the Orion's belt, right? You got a point there at the beginning, a point there at the end, and a point there in the middle. And then you need the up-down point. Which one is it? Is it this and this or this and this? Well, that's where you come back and you look at the positive and the sine. And because it's a positive sign, we know that positive sign goes up first. So I must have that point, which is in the middle straight up, and then in the middle straight down. And remember, that's what the amplitudes were for. They were to tell you how high and how low to go. And then all you got to do now is sketch a halfway decent curve, hitting those points. Now, I will say this. I do want you to sketch 2 periods, all right? Now, if you sketch 1, it's not the end of the world, but I very well may ask you on a test to sketch me 2, because I want you to get it in your head that once you know everything about a box, all you have to do is repeat it. So once I know 1, 2, 3, 4, the periods, 4 tick marks, I can't, if I want to, I can go 1, 2, 3, 4 to the right and do another one, but I ran out of room, so I'm just going to go 1, 2, 3, 4 to the left, mark another edge, and now I'm going to look at this independently. Don't go up first. You're literally repeating this exact same thing. So starting from the left, point there, point at the end of the box, point at the middle, bump up first, bump down second. And again, I'm using the middle of that to go up, the middle of that to go down, and I'm just sketching. Kind of looks like a little parabola there and there. And that would be 2 periods. 1 period here, 1 period there. I've marked the phase shift. I call the phase shift PS when I'm marking there. All right, so I've got the period, the phase shift, the D value, the A value. I've used everything and what I know about positive sine to sketch this thing. All right? Okay, so that's a positive sine curve. Now what I want to do just to kind of help you with your homework, if you go to your homework, I'm going to do one more like this. On your homework, if you look at number 2, I'm going to go ahead and do that for you, make your life a little easy. Okay? So So on number 2 on your homework, that's a negative sine curve. So let's just make sure that we can do a negative sine curve, and then you'll have a little bit of more practice with that tonight. So here we go. For a negative sine curve, let's go through everything again. What is my vertical shift? My D value tells me that. So the vertical shift is the D value, that's 3. So I'm gonna go up to 3, 1, 2, 3 high, and I'm gonna mark that. That is my new, kind of like my new x-axis. All right, so that's my D value. And then what is my, I'm trying to be consistent right here. Did I do amplitude out to the right? Yeah. So what is my amplitude? My amplitude, again, I'm ignoring the negative. That's the D value. My amplitude is 2. Okay, you can think about it as the absolute value if you want, but this tells me I'm going to go from here, not from the x-axis, but not from the x right here, but from the new thing. I'm going to go from the new vertical shift. I'm going to go up A, and I'm going to go down A, and you don't have to keep doing that, but at up 2 gives me the top part of the box. Down 2 gives me the bottom part of the box. All right, and then that gives me that. So the next thing I want you to find is the phase shift. And how do we find the phase shift? Well, I said take this, set it equal to 0, and solve. And all I have to do is subtract the pi and divide by a 2. So that tells me pi is negative pi over 2. Now, this is pi. I mean, this is negative pi. This is positive pi. What do you think negative 1/2 of pi is? And this is not a length like period is. This is a location. So if this is negative 1 pi, this should be negative 1/2 pi right there. So that's your negative 1/2 of pi. So I'm going to go ahead and mark that. That is the left side of this box going to the right, or it could be the right side of the box going to the left. All right. And then finally, I'm going to use my period to find the length of the period. And I remember I do that by going 2 pi. That period is 2 pi divided by the b. So what is the length of this period? If I cancel the 2's, I get pi. Now remember, this is a length, okay? That is a length. So I want to know on this ruler that I have, how many tick marks is that? From here to pi, which is what my period is 1, 2, 3, 4. This is 4 ticks again, and you're going to get a lot of 4 ticks because I'm trying to be nice. So you're going to do not here to here or mark it. You're not going to do that. You're going to make 4 tick marks from your phase shift. So 1, 2, 3, 4, and you're going to draw that right there. And guys, I hope you see it. This is your box. It's kind of hanging over both sides. Okay? So from this box right there, can I draw in my sine curve? But it's a negative sine curve. Well, negative or positive, they all have the 3 dots, kind of the Orion's belt thing right there, 1, 2, 3. But this time, because it's negative sine, instead of going up there, between this and this, I'm going to go down to that lowest part of the amplitude, and then between here and here, I'm going to go up to that part of the amplitude, and I'm going to connect those this way. And again, I'm going to want you to graph 2 periods. So if the length of the period right here is, if that's my period's length, 4 ticks, I can go over another 1, 2, 3, 4, put another edge. If I want to go, I can go to the left 1, 2, 3, 4. I kind of like going to the right better. That's the box. So again, beginning, middle, end. But again, negative sine, halfway down first, and then halfway up second. Connect the dots. All right, so that's a positive sine and a negative sine. Now you're going to see hardly anything changes on a cosine curve. So let's check that out. All right, so on a cosine curve, if you're looking at this, cosine, everything is found, the top, the vertical shift, the amplitudes, the phase shifts, the periods, all of it's found the same. So there's nothing new to learn there. So you're going to make the box the exact same way, whether it's sine, cosine, negative sine, or negative cosine. The boxes are all identical. The only difference is you're not going to have 3 dots for Orion's belt. And if you're like, why not? Well, again, what happens if you start plugging points in here? If I start plugging in 0 radians in there, what's cosine at 0? 1, so I'm up 1. If you plug in pi over 2, what's cosine at pi over 2? 0. That's why I'm back at 0. What's cosine at pi? Well, cosine of pi is -1. That's why I'm down at -1. So again, all I'm really doing is plotting points, but you can see if you continue to plot those points, you're going to get this kind of curve. Well, all I'm going to remember is cosines, they don't start on the middle D line, okay, or on the vertical shift. They're either going to start high right there or low right there, depending on whether it's plus or minus. So if it's a positive cosine, you're starting high, okay? Negative cosine, you're starting low. But like sine, here when you were looking at sine, you always started and finished at the same height. So I'm going to start and finish at the same height. And then if you think about it, if I've got to complete the whole cycle, I've got to get down to the bottom somewhere. Yes, it's in the middle of the period. And then that means I must be crossing the vertical shift, not at the beginning, middle, and end, but at the quarters. Okay, at the first quarter, not the second, but the third quarter, and then not the fourth. So you're going to have those 4 points if it's a positive cosine, and if it's a negative cosine, you're just going to start low. At the middle of your period, you're going to be at the high, and then you're going to be back low, and again, at the quarters, you're going to cross the vertical shift. So you're going to see, I'm about to graph a negative cosine and a positive cosine, but I'm going to do the setup almost the exact same way. All right, so let's take a look at a negative cosine. So this second graph on your classwork, this is page 71, is y equals -1 minus 3, 3x plus pi over 2. So let's take a look at this. First thing we always want to look at is the vertical shift, right? So my vertical shift is -1. So I'm going to come down here and I'm going to mark a -1, and that is the middle line, the middle horizontal line of my box. Okay, now the next thing I'm going to do is look at amplitude. So my amplitude, we're not going to call it -3. We're going to kind of think about it as absolute value. The amplitude is 3. That means not from the x-axis, but from my new horizontal axis, I'm going up 3 and down 3. So here at y equals 2, and then also here at y equals -4, these are the high and low. And by the way, if I ever ask you for a max or a min on a sine curve, a max means the biggest y value. So what's the biggest y value on this number 1 I just did? It's 2. So the max is 2. And the min would be -6, right? On this one, you can see already the max is 2 and the min is -4, because the sines and cosine curves can't go above or below the high and the low lines drawn by the amplitude. They can't go outside of that. They got to be stuck here in between those. All right, but they definitely hit them in a whole bunch of spots. You saw that above with sine. Okay, so now I have the top, middle, and bottom. Now I need to find the left side of the box. That's our phase shift. And we know the phase shift, I find it by just, sorry about that, is the phase shift. And we find the phase shift by taking the 3x plus pi over 2, setting it equal to 0, which means I've got to subtract the pi over 2. And then remember, if you divide by 3, you're going to have pi over 2 over 3, and you're going to have to multiply by a third to think through that. Well, why don't we just multiply by a third then? That gets rid of it the same way, and I get negative pi over 6. And remember, the phase shift is a location, not a length. So what is 1/6 of pi but negative? Okay, now let's think about it. This is 3.14. That's your pi. Okay, and by the way, that's just rounded to 2 decimal places. You know that. But that's actually pi. So I want to go net left, negative 1/6 of that. Well, that means pi needs to be broken up into 6 parts, which conveniently it is. So I'm going to go to negative 1/6 of that pi, and that is my phase shift. So far, right here, I've marked the D. I've gone up A, down A, and now I have the phase shift marked right here. And then the very last thing I need is the length of the period. So what is, I've been saying period, but we know that means length of the period. Well, length of the period is 2 pi over the B value, and your B value is 3. Now remember, it's a length, so let's think about this. If this is pi, 2/3 of pi would be how many tick marks? Well, since this pi was broken up into 6 tick marks, what's 2/3 of 6? That's 4, right? And look, this right here, right there would be 1, 2, 3, 4. That would be 4 tick marks, or 2/3 of a pi, which makes sense because look, 1/3 of a pi, 2/3 of a pi, 3/3 of a pi. But we want the length, not the location. So don't mark it there. Just recognize that to go from here to 2 pi over 3 is 4 tick marks. Okay? So, because this is like a ruler and I'm kind of figuring out how to move. So what I want to do is from the left edge of my box, go over 1, 2, 3, 4. So from there to there, that right there is 4 ticks. Okay? That's my period. And then now that you see it right here, can you see it? There's your left side, there's your right side, there's your bottom, there's your middle, there's your top, and there's my box. Now again, cosine is not Orion's belt down the middle. You would get, if you did that, you'd get credit for labeling and setting it up, but you're not going to get credit for knowing what a cosine looks like. Okay? So if this is a cosine curve, you got to go, wait, it's a negative cosine. So cosine's not there. It either starts high or starts low. And if it's negative, it starts low. But I do know that the whole cycle has to be completed so that the other one can start low again. So wherever I start, if I start low, I finish low. And then because this thing's got to get up to the top, it makes sense that it would have to get to the top in the middle. So I find the middle of the period and go up. And then at the quarters, that's where I'm crossing the vertical shift. And those are my 5 points. And at this point, I usually kind of connect that one like this. And then I pray. I pretend. I might pray. I pretend that it's looking like this so that I don't draw a straight line. I kind of curve it because it does kind of dip and then go back up. So I'm kind of doing a half of a down up, half of a down up, down then up. And then of course I like to have 2 periods in there. So I'm going to move another 4 ticks over, draw another right edge. That gives me another box. And then again, left part, right part, top here, and then crosses at the quarters. Okay, and then once again, this part just continues that, go up, and then another half of a down, then up, another half of this. And if you want to do more, if you want to just set up a bunch of them and connect your dots so you wiggle along, great. All right? Now, if you're wondering at all, if you're looking at this and going, you know what, how do you know that this is a cosine? I mean, I know we graphed a cosine curve, but what if I just saw it and I looked at it and all I saw was this? Why wouldn't I think it's a sine curve? Well, guess what? I can actually create a sine curve that looks like that. It would have a different phase shift, so it wouldn't be 3x plus pi over 2. It might just be 3x, or it might be 3x minus pi over 4. But all the others, and it might be a positive instead of a -3 if I go up first on the sine and then down. So a couple things might change, but actually the -1 would be the same. The 3 part would be the same. The cosine might change to sine. That negative might change to positive. And then the 3x would be the same, and the pi over 2 might change. So some things would change, some things would stay the same. But anyway, and that's a negative cosine. And then if you go to the homework, I'm going to do a positive cosine just to kind of help you out. We're going to do number 6 on the back there. So here's a positive cosine. I'm going to go a little quickly through this so we don't waste any more time or spend any more time than I already have. There's the -3. I'm going down. That's my D value is -3, right? And again, what does that mean? That's my vertical shift, okay? And then I know my amplitude right there. My amplitude is 2. So I'm going to go from that D value up 2 and down 2. And by the way, if you need to go off the graph, don't be afraid of doing that if you have to. But normally you don't need to. So if you feel the need to, make sure you're doing it correctly. All right, then I know my phase shift is found by taking this and setting equal to 0. A lot of guys get sick of writing that, so they start writing 2x equals, and then they just change the sign, put it on the other side, save a step, and then if I multiply by a half, I get x equals negative pi over 6. So I want to go 1/6 to the left. So this is a pi. It happens to be broken up into 1, 2, 3, 4, 6 parts. How convenient. So there's one of those to the left. So that is my phase shift. I'm going to put a dotted line right there to mark the edge of the box. And then I need to find the period, which again is a length. It's always 2 pi over the b value for sine and cosine, which gives us pi. But again, don't go to pi. Find out the length of a pi. So from here to there is a pi. That's 1, 2, 3, 4, 5, 6. That's 6 ticks. So my period is 6 tick marks on this graph. So from here, 1, 2, 3, 4, 5, 6 puts me to there. That is 1 period, which is 6 ticks. Okay? So look what I have, guys. I have the top of my box, the bottom, the middle, right, and the left and the right sides, and I can graph my positive cosine. Now again, positive cosine is not 3 Orion's belt. It's either start high or start low. Well, it's positive cosine, so I'm going to start high. That means I'm going to end high, and I'm going to hit the bottom part in the middle of the graph, right, the bottom, and then I'm going to cross right here at the halfway in between there. So this one actually halfway was not on a tick mark, so I'm going to have to eyeball it. It's right in between that and that because there were 3 right in between that and that. And from here, I can sketch my curve. All right. And then again, we always want 2 periods. So another 1, 2, 3, 4, 5, 6. Draw another box right there. Now that I have my box in there, beginning, end, find the middle at the bottom, halfway right there at the quarter, halfway between here and here's a quarter, halfway between here and here's a quarter, and then sketch this as good as you can. All right, well, that's all you need to do with sine and cosine. I think you have 4 problems to do for homework. Probably won't take you more than about 15, 20 minutes, which is why I'm not giving you an entirely new day to do it. And I want to finish up by Friday rather than go into Saturday or Sunday like they had suggested that we could do. So I'm going to just finish up on Friday by giving you a little bit of extra work each day. Okay? All right, guys, take care. Talk to you tomorrow.